two things hanging out that are both polar. Water's polar, right? Difference in electronegativity. Well, sodium chloride is ionic. It doesn't just have partial charges, it has full charges. So it'll hang out with water. What kinds of things would not hang out with water? What do you think will not dissolve in water?
Oil.
Oil doesn't dissolve in water. So what do you think that tells you about oil? It is, the water is polar, so oil must be nonpolar. They all like to hang out together. Okay? Fair enough? So light dissolves light. So you can't make a solution with something that's polar and something that's nonpolar. The two just don't mix very well. Okay? So, and here's a good example of this. Here we have water on top. I don't remember what they had on the bottom. Cyclohexane or something like that. Just say that this is nonpolar on bottom. And we have water on top. These are just the two layers. Here we have bromine. I think is what they have. Or is that iodine? I can't remember. No, it's bromine. Does bromine dissolve in the water? Where's it dissolved at? It's dissolved in the non-polar part down here. Okay? Why? Because when you look at bromine, is that polar or non-polar?
Non-polar.
How do you know it's non-polar? I know this is asking you to think back a couple of chapters. It's non-polar because there's no difference in electronegativity here. They're both the same. They both want the electrons the same amount. So this is non-polar. So it goes into the non-polar solvent. Now, I think this one is nickel 2 carbonate. Nickel 2 carbonate. What do we know about nickel 2 carbonate? Do we know anything about it? What type of compound is it? Is it ionic? Non-polar covalent? Polar covalent? Think about it. It has a metal and a polyatomic ion. It is ionic, isn't it? That's an ionic compound, nickel 2 carbonate. Okay? Everybody see that? It's ionic. Most ionic compounds do what in water? They dissolve. Why? Because the positives are attracted to the oxygens and the negative things are attracted to the hydrogens. So they dissolve well in water. But not everything dissolves in water. Bromine doesn't dissolve in water. Okay? Everybody see that? Like dissolves like. Very scientific sound. If you're polar, you will dissolve in water. What other things dissolve in water? Does sugar dissolve in water?
Yes.
When does it not? When it's really cold. Some of it still dissolves, just not very much, right? And we'll talk about temperature effects later on, right in the class. Okay? But it still dissolves a little bit, right? So what does that say about sugar since it dissolves in water? It's polar, isn't it? Does that make sense? Okay. So, that's what we just talked about, like dissolves like. And here's their picture's much better than mine. Look over there on the right-hand side. I want you to look at that. The sodium ions are the little purple guys, and the chloride ions are the bigger orange guys, or the bigger green guys. Look at how the water molecules surround the sodium ion to keep it in solution. Which end of the water molecule is pointed towards the sodium ion? The big fat end, the oxygen. But for chloride, it's the hydrogen atom that's pointed towards chloride, because hydrogen's partially positive. Okay? Does that make sense? These waters are often referred to, you'll hear them called the waters of hydration, the waters that are surrounding the ions. Now, when you put salt into water, it literally rips one ion at a time off of that salt crystal. That's why it might take it a couple of minutes for all the salt to dissolve. Okay? So if you dump a bunch of salt into your pasta water at home and you watch it, it might take a minute or two for it to all dissolve, but it will. Because if you stir it, it goes faster, right? Add more kinetic energy. Okay. So when salt dissolves in water, it actually breaks this attraction that's right here, and it forms ions. Sodium ions and chloride ions are no longer a solid. It is now aqueous sodium ions and aqueous chloride ions. Okay? Now, a polar molecule, like this is methanol, but some of us would be more familiar with this guy. This is methanol. This is ethanol. And we'll get there. We'll talk about alcohols eventually this semester. When you go, who in here is 21? Am I here 21? That's it? You're 21. You're 21? 21 or older. That's it? Bunch of babies in here. Okay, well, all y'all are not 21 yet. Close your ears. The rest of us are going to talk about going to the store. No, you don't want to know about this. Okay. So when you get to be 21, you'll be allowed to purchase things that you cannot purchase until you're 21, right? This molecule right here in particular, that's ethanol. So when you go to the grocery store and you buy a solution of ethanol, commonly known as that, what are you really buying? Does your ethanol dissolve in water?
Yes.
Good answer. No idea. I hope it does.
If it doesn't, it tastes so
It would taste kind of strange, wouldn't it? Because what would happen if it didn't, it would be like oil and water, right? The ethanol would sit on top, and then you'd have all the water. How much ethanol do you think you would have in that can? Not a lot, because it's only, what, like 5% ethanol. What's the other 95%?
Water.
You're paying for 95% water. You're buying a lot of water. A little bit of flavoring. Huh? Hey, that's a new thing, right? You say, I'm going to drink beer because it's good for you because it's really mostly water. It's good for you.
Dad says
95%.
Same thing with this. This is mostly water, right? Got a few other things in
some
it.
sugar and a little bit.
There's no sugar in this. This is Diet Pepsi.
Fake
So-
sugar.
Fake sugar.
Yeah, fake sugar. So, okay. Why does the ethanol dissolve in the water when you buy alcohol? Because they're both polar. That's a great answer, right? It only dissolves when they're both alike. Like dissolves like. So that tells you that the ethanol must be polar just like the water is. Does that make sense? Okay. Now, we'll talk about concentrations later on in this chapter. We'll talk about percents and all that kind of stuff. So, these problems here should be easy. Identify the solute in each of the following. The solute is the thing that's present in greater or lesser concentration? Lesser. So the one you have the lesser amount of. So for A, sugar or water? Sugar. You only have 2 grams. 2 grams not a lot, is it? Anybody ever weigh 2 grams in a lab?
Yeah.
Y'all weigh stuff in the lab, right? Use the balance? 2 grams, not a whole lot, right? Okay. 60 milliliters of ethyl alcohol or 30 milliliters of methyl alcohol. Who's the solute? Methyl. With an M. Because you only have 30 mils as opposed to 60. That's less.
Okay, I'm sorry, but question. The smaller amount
Is the solute.
is the solute and the larger.
Is this larger is the solvent.
Solvent.
Yep.
The fact that it's two separate.
Doesn't matter. They will dissolve in one another because they're both alcohols. They will dissolve each other. Yep. So 55 milliliters of water and 1.5 grams of sodium chloride. Sodium chloride, right? Water, dump a little bit of salt in it, got a solution. Sodium chloride is a solute. 200 milliliters of oxygen or 800 milliliters of nitrogen? Oxygen, that's basically the composition of the air in this room, right? It's about 80% nitrogen. Okay? Now we just talked about this one. Lithium ions are attracted to oxygen or hydrogen?